There's no good way to start this, but because it's not going to match the importance of what I'm about to say. So I'm just going to lay it out to you. The year is 1900s. The guy is Max Planck. After 6 years of work on a problem, he finds a solution. In complete desperation, he doesn't know the importance of the solution and how it's going to change the core of physics for the next 100 years. Quantum physics. Trying to understand quantum physics. This thing has been staring at me. I try to understand it. I've been trying to understand it over the years, and it's tough, it's difficult, it's hard, but some things have changed. Some things have changed because I read some books. Adam Becker, this guy wrote a book called What is Real. I bought this book, I read the book, half of the book, and I realized this story of quantum physics is a fascinating historical story. It's a story with amazing characters and ideas. It's a story of challenging authority. It's a story of suppression and corruption and war and deceit. It's a story with a big desire to understand the world, of what happens to us as a collective when we can no longer understand the world, when we can no longer make sense of what is going on in front of us. Yes, it's a great human drama, and I hope to tell that story here on this channel. It'll take me years. But first, let's go to the origin of the word quantum. What does the word quantum mean? See, what happened at the end of the 19th century was that physicists were really confident of the fact that we have just finished physics. Physics is going to be over soon. It's just the last leg. Only a few wrinkles are left here and there. We have figured out everything. We have figured out the whole picture. And one of those problems, one of those wrinkles was the ultraviolet catastrophe. What is this? What is this ultraviolet catastrophe? This is the truth of the universe. Everything is shaking. Everything shakes. The atoms in my hand, the atoms on my face, this table, this phone, this microphone, this camera, this light, your face, your hands, everything shakes. Anything you see, the atoms in that thing are shaking. That's the truth of the universe. That's what temperature is. The more something shakes, the hotter it is. If things stop shaking, that only happens at absolute zero. Absolute zero is minus 273 degrees Celsius. That's the lowest possible temperature in this universe. You cannot get lower than that. And if you have to stop things from shaking, if you have to stop atoms from shaking, you have to take them to that level, and it's impossible to go to that level because then the volume would be zero and everything would collapse, and that's another problem. So you can go deep into that also. You can make yourself really uncomfortable with all the facts in that domain. Well, when things shake, especially when electrons shake, everything has electrons, right? Atoms basically are just this nucleus in the center, all the masses in the center, and the electrons are in a cloud outside, kind of. And if the electrons are shaking, they will give off some light. They will give off. That's how all light is. All light in this universe, all light you see, all light happens because electrons are going up and down very quickly. Now, light is a wave in the electromagnetic field, which means just like there are waves in water goes up and down, wave goes across. Similarly, electric and magnetic fields go up and down and the waves go across. Waves in any substance have two different properties that we are interested in. How much does the electromagnetic field go up and down is the intensity of the wave. And how quickly does it go up and down is the frequency of the wave. Low intensity, high intensity. Low frequency, high frequency. This was all known before the 20th century, except for this one just tiny wrinkle called the ultraviolet catastrophe. Think of me as the electron. I am the electron, and I have this much energy with me. When I shake, I give off energy. I mean, I get energy as well from the surroundings because everything else is shaking, and that's also giving off energy to me. So I never really run out of energy. Let's say this is low frequency and this is high frequency. The visible spectrum, what we can see. At room temperature, most of the radiation is lost at lower frequencies. Almost none of it is in the visible range. Something like this. Most of the energy is over here. As you heat up, doesn't matter what material is, as you heat up the material, the energy kind of shifts towards the visible spectrum. The more temperature you increase, the more it goes towards the visible spectrum and ultraviolet. But it kind of peaks here. Even at the temperature that the sun is. The sun gives off most of its light in the visible spectrum. That's a great coincidence, right? That our sun gives off energy in the spectrum that we can see. Well, not true. We have evolved so that we can see the particular wavelengths that are actually the most abundant. Our sun has maximum energy radiated at visible spectrum. The more you increase the temperature, the more it will go higher and higher towards the ultraviolet. See, before the 1900, we had classical physics and we had mathematics that came out of the properties of waves and thermodynamics and electromagnetism. And all that mathematics was based on statistical mechanics, which handles numbers in big quantities. When something happens in large quantities, you can make assumptions. You can statistically predict things. One coin toss, I have no idea what's going to happen. 50% probabilities heads, 50% probabilities tails. But if I toss 50 coins, I can bet on it that more than 40 are going to be heads. I can be pretty sure. So I can make some assumptions because the number is so huge. Similarly, statistical mechanics can make assumptions. And one of those assumptions is that energy in an electron is going to be distributed equally in all ways in which it can be distributed. This principle is called the equipartition of energy. This is a coin from 1973. 2 paisa coin, no longer useful to buy anything. I am dividing the number of heads and number of tails equally in the two equally probable cases, right? Similarly, electron is giving off energy in different frequencies. It is going to give off energy equally in all modes. This is actually what I do not completely understand, and it's a lot of mathematics in it. If you have a string tied at two ends, the lowest frequency that it can vibrate is this. Second harmonics, third harmonics, fourth harmonics, fifth harmonics, sixth harmonics. It can go on and on. The higher the harmonic, the more modes it has. Higher frequencies will have a lot more modes than lower frequencies. As we approach higher and higher frequency, the energy that is going to be released in that frequency is going to be higher and higher and higher and higher, so much so that all the energy is going to be dumped here on this side. All of it. I can't really. This is what they thought. This is what the mathematics said. That all the energy would be up till here. Clearly, that's not the case. Everything in this world is going to lose all of its energy in higher frequencies almost instantaneously and go to 0 Kelvin. Clearly that is not happening. Clearly that is not true. And look at what I have. 1/4 Anna, India, 1940. This is a coin from 1940. Oh my god. So Max Planck worked on this problem for 6 long years. 6 long years without understanding why is the math not working. Why can't I get mathematics to follow the data? So he did what any math student under desperation would do. He cheated. He manipulated the mathematics in such a way as to fit the curve exactly. He said that energy cannot be continuous. Energy has to come in small packets. There is a minimum quantity. Some 10 paisa coin, some 20 paisa coin. Wow. Just like I cannot buy anything for 10 paise anymore because no one will accept. The minimum I can spend now in this economy is 1 rupee. And this is what Planck said. Planck said there is a minimum small packet of energy. The higher the frequency, the bigger the packet that is required. To give you a nice analogy, think of the electron as running a company, and every frequency of light is like an employee in that company. Lower frequency is entry-level employees, higher frequency is mid-level employees, and highest frequency is the CEOs. It's easy to fulfill the salary of lower-level employees. It doesn't require much energy. It's a small salary package. Mid-level employees still require a lot of energy, but not too much. But to give off higher level frequencies, you need extremely large amount of energy. You cannot give off high frequency radiation in small quantities. It's like the CEO would refuse to work for you if you don't give them a lot of money. Only really multinational, multi-billion-dollar corporations can hire big CEOs. Just like the sun is, or something really hot like the first few millionths of a second of the Big Bang. This is what he said, and it fit the data. And he was not happy with it. He wasn't happy with the solution. He said it's cheating. But Einstein came along and said that not only is Planck right, but that is the only way in which energy can exist. A minimum quantity, a minimum quantum of energy that has to be fulfilled. And that was the start of quantum mechanics. People had almost thought that physics was over. Turns out it hadn't even really started yet. We hadn't even come close to understanding the reality of the universe and what was about to come in the next century, in the next few years, with some really strange experiments, especially the double slit experiment that happened with one electron at a time, which really revolutionized physics, and that we will discuss in the next video. So I don't fully understand the mathematics of this ultraviolet catastrophe. There are some videos I'll link in the description. There is this one really nice video by this channel called Physics Explained. I would leave you here with the link. Does this video even make sense? Am I saying something wrong? Let me know. Like, share, subscribe. And if you have a better explanation of the ultraviolet catastrophe, some intuition about the mathematics, let me know. Thank you very much. Bye bye.